Newton's laws of motion.
Isaac Newton is considered one of the most important scientists in the history. During his lifetime, Newton developed the theory of gravity, the laws of motion, a new type of mathematics called calculus, and made breakthrough in the areas of optics such as the reflecting telescope. The three laws of motion were first compiled by Isaac Newton in his Mathematical Principles of Natural Philosophy and was first published in 1687. Newton's first law of motion states that every object remains at rest or of uniform motion in a straight line unless the application of a net unbalanced force causes it to change its motion. There are two conditions on which first law of motion is dependent. Objects at rest. When an object is at rest, velocity and acceleration are zero, therefore the object continues to be at rest. Objects in motion. When an object is in motion, velocity is not equal to zero, while acceleration is equal to zero. Therefore, the object will continue to be in motion with constant velocity and in the same direction. Inertia. Inertia is the natural tendency of an object to continue its state of motion or rest. In other words, inertia is the property of the object to oppose the change. Inertia of rest. It is the tendency of the body at rest to remain at rest itself. Inertia of motion. It's the tendency of a body in motion to continue in motion itself. For example, the fan continues in motion even after the switch is off. Some examples of first law of motion. The passengers in the bus will fall backward when the bus starts suddenly. Only the carom coin at the top of a pile is removed when a fast-moving carom striker hits it. The dust particles comes out of the carpet due to inertia of rest. Whenever a carpet is beaten with a stick, carpet comes into motion, but the dust particles try to resist this change. When we shake the branch of a tree, the leaf may have the tendency to continue rest itself. It is due to inertia. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force is applied. Second law of motion formula. Let us consider an object of mass m moving along a straight line with an initial velocity u. Let us say after a certain time t with a constant acceleration, the final velocity becomes v. Here we see that the initial momentum p1 is equal to m into u. The final momentum p2 is equal to m into v. Change in momentum can be written as p2 minus p1 is equal to m into v minus m into u is equal to m into v minus u. As we know, the rate of change of momentum with respect to time is proportional to the applied force. The applied force F proportional to m into v minus u by t. F proportional to ma, as acceleration a is equal to rate of change of velocity with respect to time. F is equal to k into m into a. The above equation is the equation for the second law of motion. Equation F is equal to m into a, where F is force, m is mass and a is acceleration. The SI unit of mass and acceleration are kilogram and meter per second square respectively. So unit of force K into 1 kilogram into 1 meter per second square. The second law of motion gives us a method to measure the force acting on an object as product of the mass of the object and the acceleration of the object, which is the change in velocity with respect to time. These are some of the real-life examples of second law of motion. Newton's third law of motion states that every action has equal and opposite reaction. Some real-life examples of Newton's third law of motion. When a person pulls down on a vertical rope, the rope pulls upon the person. When someone swims, force given from his hand to the water results a resulting force from the water with the total force as big as his hand's force, but in the opposite direction, so that he moves forward even though he swings his hand backward. As our legs propel our body towards the dock, they also apply to the boat an equal force in the opposite direction which pushes it away from the dock. Newton's laws of motion forms the basis of physics. These three statements have led to progress in the field of technology and science. It paved the way for many inventions and discoveries. Most observed phenomena are the complicated manifestations of these laws. But we have only covered a fraction of our journey to understand nature and its laws. Many doors are waiting to be opened by us. Isaac Newton opened the first door by giving these laws of motion.